Operations on radical expressions. In this lesson we'll be adding, subtracting, multiplying, and dividing radical expressions. If possible, simplify the expression. Assume that all variables are positive. 2 square roots of 3 plus 7 square roots of 3. You can add these radicals, since they're like radicals, the same way as we would add something like 2x plus 7x. So what we have is 2 of these radicals plus 7 more of those radicals gives us 9 of the same radical. Here I have again like radicals. 4 cube roots of 5 plus 2 cube roots of 5 is 6 cube roots of 5. So we must have like radicals in order to add or subtract. For them to be like radicals, they have to have the same index and the same radicand. Square root of 2 plus the square root of 18 minus the square root of 32. This problem at first seems that we can't do anything because we have unlike radicals. But you'll notice these two radicals are not simplified. We first need to simplify those radicals, and then we'll see if we have any like radicals to combine. So first with 18, 18 is 2 times 9, 9 is 3 times 3. With 32, it's 2 times 16, 2 times 8, 2 times 4, 2 times 2. So this problem is the square root of 2 plus the square root of 3 squared times the square root of 2 minus the square root of 2 to the 4th times the square root of 2. That gives me the square root of 2 plus the square root of 3 squared is 3 square roots of 2 minus the square root of 2 to the 4th is 2 squared, which we know is 4 square roots of 2. Now we have 3 radicals that are like, and we can put them together. 1 square root of 2 plus 3 square roots of 2 is 4 square roots of 2 minus 4 square roots of 2 is 0. The 4th root of 48 plus 4 times the 4th root of 3. Again, it looks like we have unlike radicals and cannot perform this operation, but we need to simplify the 4th root of 48 first. So we'll take our 48 and separate it into its prime factors. And then we can break that radical up into perfect fourth powers and its leftover fourth powers. So we have 1, 2, 3, 4 2's and a 3 that's left over, plus our 4 fourth root of 3. So with this step, we've simply broken this into this and copied down 4 times the 4th root of 3. So here the 4th root of 2 to the 4th is 2 times the 4th root of 3 plus 4 4th root of 3. Then when I add those together, I have 6 4th root of 3. Again, with this problem, I need to first simplify my radicals and then determine if I have like radicals to be able to add. So my 8k, I know I'll be able to break that up as the square root of 2 squared, and then my leftover will be another 2 and the k. So the 8 is 2 cubed. I put 2 of them here and 1 here. We only have 1k, so it goes into the leftover radical. Now we're ready to separate this. So we have 2 square roots. 18 is 2 times 3 times 3. So I can put 2 3's here, and the 2 has to go there. k has to go in the leftover. Now I'm ready to simplify further. I get 3 square root of 2k plus the square root of 2 squared is 2 square root of 2k plus the square root of 3 squared is 3 square root of 2k. Now when I add these up, I'll have 3 of those roots plus 2 more of those roots plus 3 more of those roots gives me 8 square root of 2k. The square root of 25x cubed minus the square root of x cubed. First we need to simplify both radicals. This may look simplified, but remember the exponent is greater than or equal to the index, so we know that it's not simplified. So I'll break up both of those radicals. That gives me 25 is 5 squared. X cubed can be broken up as x squared and x in the leftover radical. Then x cubed is x squared and x in the leftover. Now simplifying the first, I have 5x square root of x minus x square root of x. Now I have like radicals. I also have like terms. I have a 5x and a negative 1x, so like terms and like radicals. So I have 5x radicals minus 1x radicals gives me 4x of those radicals. 15 square root of 8 over 4 minus 2 square root of 2 over 5. We have a dual problem here. We first need to simplify this radical, and then we're subtracting fractions. Remember that we'll need to have common denominator in order to subtract. So first things first, let's simplify this radical. I have 15 square root of 2 squared square root of 2, because 8 is 2 cubed, all over 4, minus my 2 square roots of 2 over 5. That gives me, for my first radical, 15 times 2 times the square root of 2 all over 4 minus 2 square roots of 2 over 5. That gives me a 30 square root of 2 over 4 minus 2 square roots of 2 over 5. Now to get a common denominator. Looking at 4 and 5, the least common denominator is going to be 20. So I'll need to multiply this radical by 5 over 5 and this radical by 4 over 4. So this gives me a 5 times 30 is 150 square roots of 2 over 20 minus 4 times 2 is 8 square roots of 2 over 20. Now I have a common denominator. I have like radicals on the top, so I can go ahead and subtract. I get 142 square roots of 2 over 20. Now I see that this and this, they're both even. So I can go ahead and take a factor of 2 out of them. So I have 2 goes into 20 10 times, 2 goes in 142 71 times. So that gives me a 71 square roots of 2 over 10 as my final answer. Multiply and simplify. Here I have a binomial times a binomial. If you'll notice, this is similar to a problem like a plus 2 times a minus 2. What happens when I have some kind of multiplication problem like that? I know that I'll have a squared minus 2a plus 2a cancels out, and a plus 2 times negative 2 is minus 4. So we have a product of a sum and a difference as a difference of squares. When we see that's going to happen, all we need to multiply is the first to get the first term and the last terms to get the last term. So we'll do the same here. Let's go ahead and do it the long way first so you can see for sure that those middle terms really will cancel out. So I have 3 times 3 is 9. 3 times negative square root of 7 is negative 3 square root of 7. Square root of 7 times 3 is a positive 3 square roots of 7. And square root of 7 times a negative square root of 7 is negative square root of 7 squared. Now we can see that the middle drops out, and I have just a 9 minus the square root of 7 squared is simply 7, and 9 minus 7 is 2. Kind of a neat problem where we're multiplying two numbers with radicals and we get something that is not a radical. Here again, the square root of ab minus 3 times the square root of ab plus 3. We know that our middle terms are going to drop out because this is the product of a sum and a difference of the same terms. So we'll go ahead and just multiply the first and the last. Square root of ab times the square root of ab is the square root of ab squared minus 3 times 3 is 9. That gives me the square root of ab squared is ab minus 9. Again here, the square root of ab minus the square root of c times the square root of ab plus the square root of c. So I have a square root of ab squared and a minus square root of c squared. And that gives me an ab minus c. Rationalize the denominator. When we have instructions that say rationalize something, it means to get rid of the radical. And so they're saying to us to get rid of the radical in the denominator. Now, you might not naturally see how to do this, so I'll do this first problem here. If we multiply this by the square root of 7 over the square root of 7, that's perfectly legal because we're multiplying by another form of 1. When I do that, watch what happens. I get a 1 times the square root of 7 is the square root of 7, and the denominator is the square root of 7 squared. So I have the square root of 7 over 7, and I've taken the radical out of the denominator. Let's try that again on this problem. 4 over the square root of 3. So if I have 4 over the square root of 3, the reason that that radical is still a radical is I don't have enough 3's to come out. So I'm going to multiply in another 3 in the denominator, and as long as I do the numerator as well, I'm multiplying by 1, so I haven't changed the value of that radical. That gives me a 4 square root of 3 on top and a square root of 3 squared on the denominator, which is a 4 square root of 3 over 3. Let's go ahead and grab the calculator so you can see that this is the same as 4 over the square root of 3. 4 divided by the square root of 3, close parenthesis, equals. That's our original radical. And if we try this, 4 times the square root of 3 over 3, I have the exact same decimal approximation. So you can see that these are equivalent. Now, what's important about rationalizing a denominator is that it's now your responsibility to rationalize any denominator that comes along. If you have an answer that ends up as 4 over the square root of 3, you won't be finished there. You'll need to rationalize the denominator, and this would be your final answer then. Square root of 5b over 72. All right, first let's simplify this by going ahead and writing as prime factors. Now I know that 72 is 8 times 9, and 8 is 2 times 4, 4 is 2 times 2, 9 is 3 times 3. So I really have the square root of 5b over the square root of 2 cubed times 3 squared. Now looking at that denominator, I have no problems with the 3. The 3 will be able to come out nice and neat because the exponent on it is a multiple of the index 2. With the 2, I have an odd number. So what I need to do here is just multiply in another square root of 2. So watch what happens. On the top I get a square root of 10b. On the denominator I'll end up with a square root of 2 to the 4th, 3 squared. And both of those will be able to come out nice and neat because the exponents are now multiples of the index 2. So I'll have a square root of 10b on the top, and on the denominator I'll have a 2 squared times 3. So when I simplify this, go ahead and multiply the numbers in the denominator. That gives me a 4 times 3, which is 12. And that's my final simplified answer where I've rationalized the denominator. Here I have another that looks quite difficult, but we can just break this down. 250 is 10 times 25. 10 is 2 times 5, and 25 is 5 times 5. So I really have a 7 over the square root of 5 cubed times 2 times a cubed. So I don't have enough of anything to come out in the denominator. I'm needing to multiply by quite a bit here. So I have 3 5s. If I'm taking a square root, then I need that exponent to be a multiple of 2. So I'll need another 5. I have 1 2. So if I can multiply by another 2, then I'll have an even number of 2's to come out. And I have an a cubed, so I need one more a so that it makes it an a to the 4th and can come out of the radical nice and neat. Now we go ahead and multiply the numerator. We get 7 square root of 10a all over the square root of 5 to the 4th, 2 squared a to the 4th. That gives me 7 square root of 10a on top. And on the bottom, I get the square root of 5 to the 4th is 5 squared. Square root of 2 squared is 2. And the square root of a to the 4th is a squared. So that gives me a 7 square root of 10a all over. 5 squared is 25 times 2 is 50 a squared. Now we have a rationalized denominator, no radicals in the denominator. That covers this lesson. Go ahead and try your homework. Be sure to let me know if you have questions.